This is LeetCode problem 19. Remove nth node from end of list. Given the head of a linked list, remove the nth node from the end of the list and return its head. To solve this problem, let's see how node removal works first. In order to remove node B, we need to access to node preceding it, which is node A, and then so we can redirect pointer of node A to skip over node B to point to C directly. So that means in order to remove nth node from end of list, we need to find the node directly before the nth last node. We can use two pointers technique. When fast pointer reaches the last node of linked list, we want slow pointer to end up at node right before the nth last node. In other words, fast pointer should be n nodes ahead of slow pointer when fast pointer reaches the last node. We can start by advancing fast pointer through linked list for n steps. When fast pointer is n nodes ahead of slow pointer, we can advance both pointers together until fast pointer reaches the last node. For the edge case, which is the head itself is the node we need to remove. In this case, there is no node before the head, so we cannot perform removal. To circumvent this, we can create a dummy node, place it before head node, and start our traversal from there. This is the coding part. We first initiate a dummy node to ensure there is a node before head in case we need to remove head node. Dummy node value is 0 and it points to the head of linked list. Both fast pointer and slow pointer start at the dummy node. From there, we advance fast pointer n steps ahead. For underscore in range n, fast equals to fast.next. If n is larger than the length of linked list, no node need to be removed, we just return head. Then we move fast pointer to the end of linked list, keeping slow pointer n nodes behind. From there, we remove nth node from the end. Slow.next equals to slow.next.next. Eventually, we return dummy.next. Time complexity is O of n, space complexity is O of 1.